So the dependency of resistance, or by how many factor the resistance is affected. Okay, so here we have the resistance R. Can you consider a simple water pipe? This is a water pipe. Okay. If it is a water pipe, the water flows simply. Okay, the water flows. Now, if the length of the pipe is increased, if you increase the length of the pipe, can you tell me the water flow will be increased or decrease? A little, obviously. Tell me, if the water pump, this water pipe, the length of the water pipe is increased, simply what we have, that is that it takes more time to flow water from this point to this point, and the water flow will be decreased. That means now if you consider these two are the two electric wire, and the electric charge, these all are nothing but the electric charge flows from A towards B. If you increase the length of the wire, if you simply increase the length of the wire, it is simple that the resistance will be increased. Why? Because the flowing of the electric charge will be decreased, the rate of current will be decreased, because it takes more time to reach this point from this point for the electric charges. Current is nothing but the summation of the electric charges. So that is why the first factor which is affected the resistor, that is what? Length. So if you increase the length of the wire, resistance will be increased. So when resistance will be increased, simply we know the rate of current will decrease. Okay, or the flowing of electric charges will decrease. That means the resistance is directly proportional to the length of the wire. Got it? The first segment, the first factor of dependency is the length. So I have already introduced the rule of length. That is the number one dependency. The resistance is dependent upon the length in that way. The equation is R is directly proportional to the length. That means if you increase the length, automatically the resistance will be increased. The next one is the cross section. Cross section means here it is. This is the cross section. So think about it. This is the water pump, water pipe or tube, whatever. This is another one. This is another one. Okay. So tell me, in which tube the water flows more? This or this? Obviously this, because the cross section is here larger than the second one. So if the cross section is larger, that means the more water can flow, the more water can flow. The same thing happens. The more electric charge can flow, and when the more electric charge can flow, that means the rate of current will increase. So that means resistance will be decreased. Okay, so that means the more cross section area, the more increasing of the cross section area, the more decrease of resistance. Because if you increase the cross section area, the rate of current, the number of the charges, electric will increase. So when the electric charges will increase, when the rate of current will increase, automatically the resistance will be decreased. So simply the resistance is inversely proportional to the cross section area. Understand why? I already told, that is what? If you increase the cross section area, more current can flow, the more electric charge can reach from this side to this side. That means automatically resistance will be decreased. So this is the two greatest factor which is affecting the resistance. But The thing is what? When, for the first rule, when the R is directly proportional to the length and when R is inversely proportional to the cross section, we must have to write here when here A is constant, must be when A is constant, or here when L is constant. Okay, that means when you considering the length, your cross section must not be changed. And when you considering the area, the cross section area or the cross section, the length must not change. This is the basic rule. And the third dependency is the substance by which the wire is making of. The entire wire can made by the iron, can made by the copper, can made by the silver, can made by the gold. So R is also depending upon the substance by which the entire wire is made of. So for the first rule is R directly proportional to the L when the A is not changed. For the second, when the L is not changed. So what we got from these two equations, R is directly proportional by L by A. Got it? So then if you want to remove this sign and got it the equals to sign, that is what? We have to put here simply a constant. Okay, the constant is nothing but this, and this is called resistivity. Here is a new constant I have introduced, that is called rho, and this is nothing but the resistivity, or you can say the specific resistance. This is exactly the new constant. This is what? Resistivity or the specific resistance. So in this equation, take it as a 1. In this equation, when, okay, so before going to further, in here you can write here the A and L both are changed. In that way, same thing, both are changed. Okay, so then if you simply put L equals to 1 and A equals to 1 in that equation, L equals to 1 and A equals to 1, simply we got rho is equals to R. Rho is the resistivity or the specific resistance, so rho is equals to R. That means when any conductor or any electric wire having length exactly 1 centimeter, or that can be other unit also, 1, and also the area is unit length and unit area, the resistance of that wire or the conductor is simply called the resistivity or the specific resistance. Okay, so simple. If you suppose this is a wire, electric wire or a conductor, electric wire or electric conductor, where the L is equals to 1 and A is equals to 1. That means unit length and unit area. You can consider it centimeter also, unit length and unit area. Then the resistance for this conductor or the resistance in these 2 points is called what? Resistivity or the specific resistance. Or you can give it in that way also. If suppose this is a unit cube, unit cube means the L is equals to 1 and also A equals to 1. That means each side of this cube is exactly unit, the centimeter or other unit also. So if L equals to 1 centimeter, then A equals to 1 semi square. If it is 1 semi, that is 1 semi square, right? Here also 1 semi square, not the semi square. 1 equals to L equals to 1 centimeter and A equals to 1 semi square. Then what will be the rho? Here the rho equals to the resistance. Rho equals to the resistance, or that means for the unit cube, the resistance of two different side is called resistivity or the specific resistance. You can get the definition in your book, but this is the explanation of how to get the rho or the resistivity or the specific resistance, how to get the definition of it, and then let me introduce what will be the unit. So rho, if it is rho, so the rho equals to what? Rho equals to R into A by L, right? What is the unit of R? Ohm. What is the unit of A? That is semi square or meter square, whatever. What is the L? That is semi. Simply what you have? Ohm into semi. So that means that can be ohm into semi and also ohm into meter. So that is the unit of resistivity or the specific resistance is ohm into semi. So in CGS we have ohm into semi, in SI we have ohm into meter, simple. So in that case there is 1 ohm into semi. Now, I can't say there is 1 ohm semi because you have to measure the resistance. What will be the actual resistance? That can be 7, that can be 8, that can be 9, whatever. So the value here, ohm into semi, is called the resistivity or the specific resistance. Here also, this is when this is a unit conductor of the wire, when you measure the resistance, right? So L, A, both are 1, the value you got it, maybe the X ohm semi, you got it. This is nothing but the resistivity or the specific resistance. So in the next content we will go a little bit of numerical problem regarding with these equations.